All right, thank you everybody for coming. My name is Baruch Berger. I'm going to be talking to you about Clojure in combination with STARCRAFT 2. The title of the talk is Clojure Script 2, Clojure STARCRAFT 2 Whiting, and Whiting is Korean for fighting, which is basically saying, let's go. They always do that before they do like a StarCraft match or any kind of challenge. The title further is Learning StarCraft 2 at 10,000 game steps per second. So I'm going to be talking a bit about who I am, what StarCraft is, what Blizzard and DeepMind, those companies are up to, and about how the project came to life, what's it doing now, and I'm also going to talk a little bit about Focro, which is the framework I'm using to do the front end and the back end communication in Clojure and Clojure Script. Talking a little bit about the community behind my project and also the larger StarCraft 2 project, and what I can say is the AI part of what I'm making and what's underway, so for the future. So as I said, my name is Baruch Berger. I'm currently based in South Korea. I'm mostly a web developer, and I've met my girlfriend in Shanghai, working there for 2 years, and then we moved to South Korea. I studied software engineering and at the Hogeschool Utrecht in Utrecht. I was two for this story important things happened there. I was introduced to Clojure actually by someone in the audience. He was my teacher there. And I've also played too much StarCraft 2. Maybe not too much because it's fun. But yeah, I mostly build web apps, and my proudest work would be, I guess, the data.worldbank.org, which is an open data set website that a lot of people use whenever you search something on Google, like population of X, and you usually find the data.worldbank.org. And I do JavaScript and Python mostly for renminbi, euros, and Korean won. And I do Clojure and Clojure Script for just because my heart needs it. And also recently someone started helping me out a little bit financially, paying me Bitcoin for it. So first of all, who here knows what StarCraft is? Who's heard of it? Okay, most of you. So it's a competitive game. It's a real-time strategy game. It's also called chess at hyperspeed. So chess is seen as a thinking sport, and so is this, except you also have to be really fast about your controls. And then what do you control? You try to control resources, like minerals and Vespian gas, and you can use these to invest into your production facilities, with which you produce more economy or more army, and you can also invest in upgrades. Players that play the game in a 1v1 setting, they make high-level decisions, more strategical decisions. And this is called macroing, the macro decisions. And the smaller level decisions where you actually try to execute these things that you want to do is called microing. And people tend to start to micromanage really quickly. And this game is really good at whipping you, saying you focus on the wrong thing. You're always focusing on the wrong thing, basically. So you execute these decisions through mouse actions and keyboard actions. You can measure the performance of a player in APM or eAPM, which is effective actions per minute. The exact way you calculate it is, of course, hard because how do you know what's effective? But this game is played by professionals. Already in the years, in the early 2000s, this was televised in South Korea, where you have like the 15-year-old, 17-year-old diehard gaming kids battling it out, and it became actually quite serious industry. By now, eSports is one of, multi-billion-dollar industry, and it's really awesome to see that in South Korea, these players, they get so much recognition if they're dominant that they're kind of seen as idols. Like there's one of the players who used to be the best 10 years ago. Still, if he's like at one of those events, people will ask his autograph, and yeah, so Koreans are really good at this game somehow. They're good at several games, but StarCraft is definitely one of the number one, like the number one game they're really good at. And it's like this, that when anyone in the world talks about StarCraft, they basically talk about the Koreans versus the foreigners. There's no other nationality, it's just the foreigners versus Koreans. And in recent years, it's been a couple times where a foreigner actually makes an upset and wins from South Koreans. So foreigners are not doing that horrible, but Koreans are still dominant. I'll show a short clip of the first-person view of a player. This is still fairly early in the game, but it just shows the sheer speed at which you need to micro and also macro. So you can see him, making a lot of actions. You can't actually see what all is doing, like everything that he's doing. Even after playing this game for years, I still don't know. Yeah, I still miss actions that he's doing at that moment. But yeah, it's very, very mechanically demanding. It's really awesome to watch. And yeah, there are many tournaments. Like every weekend, there's a big tournament that you can watch. Next slide. So another popular game in Asia is a 2,500 years old game called Go, or Baduk in Korean. In Japan and Korea and China, this has been part of their culture for a long time. It's basically Asian chess, Asian chess it's also called. And when children play this game and they turn out to be good, then they get put into a school where they play this full time through their teenagers. And they can just make a lot of money just playing this game. There's an English company bought by Google called DeepMind. And in 2016, they trained their AI, their neural networks, their deep neural networks, to play this game. And it was thought that this game was really hard to ever build an AI for that could beat humans, because it has to use intuition, because the sheer number of possibilities in this game is too high to ever calculate. Whereas chess, you can calculate all the possible moves of the whole game with a decent sized computer, and it's just physically impossible to do this for Go. So when the DeepMind bot beat the legendary South Korean player, it was kind of a shock to him and also to the rest of the country. Like it was kind of like they were in mourning a little bit. And the South Korean government responded by injecting $860 million fund into the South Korean economy. And it's not all bad. It sounds very dramatic like this. Also, the player said it reinvigorated his love for the game, because the game has certain rules, like you don't make this kind of move, it's bad. But actually, the AI started making them and making it work. So it opened up new possibilities for the Go players. I remember watching this with my girlfriend in Shanghai at the time, and I was like, wow, it's so exciting, this kind of stuff happening. And then I read an article with Demis Hassibis, who's the CEO of DeepMind, and he said in the interview that they might tackle StarCraft next. So as a StarCraft player, I was really excited to read this. I was like, please be StarCraft 2, not StarCraft 1. So about 1 year later, I guess the DeepMind and Blizzard came out. Apparently Blizzard read this blog too, and they got in touch. So that's really awesome. And they came out with the StarCraft 2 reinforcement learning environment. And it's supposed to be a way for code, for your programs to interface with StarCraft 2 and do this so in a fair way. So you see here, I use the term level playing field. Over here you can see at the top, this is what a human would have to do to give an action. So it's a worker unit, and he wants him to build something over there. So you see all the actions that the human would have to take. And they try to, if you would write a program, you could just send a single command, because you already have all the data, you can just send one command. That's not really fair, so they try to make an API where the computer has to basically do the same as the human, or as close as possible. For example, if you get the raw data, it's still possible, but you only get raw data that is visible to the human as well, so you cannot get the full game state. And that's one of the challenges of StarCraft, is in the game of Go, you can see the whole game at all times, and you know the rules, so you know everything that's going to happen, so you can calculate forward. In StarCraft 2, there's a fog of war, so you cannot see what the enemy is doing unless you go there and actually watch him do it. So there's a lot of mind games involved between professionals, and you have to make a judgment from what you see, what is going to come next, because they might go a certain direction that you did not expect, and then you lose. So that's one of the big challenges, imperfect information problem, and that's what an AI would have to solve to win this game. So at the time when they came out with initial research, their current neural networks, how they performed on certain small parts of the game called mini games. So it's not super impressive, but recently, actually last week I think, they came out with a next paper that I still have to study, but they got way better results than some of the mini games. And it's very exciting to read and very cool that they're open about it. So the release contained a binary, so you can run the game on Linux, OS X, and Windows, which I don't use. And it came with a bunch of minigames and replay data, so it gave all the replays of the one versus one ladder of the humans. So some machine learning algorithms need to learn from how humans play it, so it can already decide, oh, okay, this move is likely to be good because humans did it sort of in this time period. So they gave that data. And also, the way you interface with the binary is by using Google Protobuf, which is a very low-level protocol for sending data back and forth. So I think this is perfect. I want to use Clojure to do this. This is like a perfect excuse for me to learn about machine learning. And I thought, okay, let's bring it to life. So I started working on that. My goals were basically to have fun while making computers play my favorite game. Learn more about all kinds of statistics and machine learning techniques. And also just to make a full-blown Clojure/Clojure script real world project. I had built some Clojure stuff before, Clojure script before, but not really of this scale, I guess. So I think, okay, this is Clojure. If you don't have a Clojure library to do it, you have a Java library to do it. There was a Clojure library for it, but it was not well maintained, which is kind of surprising since it's a pretty big thing, I guess, the protobuf. However, it was sort of usable. I can deserialize data, so I can read from the client, but I cannot serialize it. So I had to, I think, okay, I'll try to use the Java library, but it's super object-oriented in a way that has like sets and gets, and they're all different tiny bits depending on the type of data. And I was like, just give me a raw bunch of data, like it's normal in Clojure. So this is one of those. This is a specification file. It's just a text file, .proto it's called. This is a protobuf file. So basically, it's about 10 files that are, I don't know, quite long with this kind of stuff. And eventually, this is kind of like a class, and it can have an instance or like field or attribute of that type. And you can look it up inside the file or inside a different file. It doesn't really, it's just a text file you would have to go through and look. However, I think this is called a specification, and there's something called Clojure.spec, and I've used it a little bit, and I think it's a good match. So one of the things that has been added in Clojure 1.9 is namespace hashmaps, namespace data structures. So usually you have a hash map, which is just name, value, key value, key value, key value. But you can have a map that has namespace in front of it, so you don't have you have less collision chance when you do that. So it takes a while to get used to this kind of syntax, but it's really nice to work with. You can use all the Clojure functions and the regular way you query data structures with this kind of syntax, and it was really good to do this. Making specs out of it has helped in many ways. So what I had to do is actually find out the grammar, the EBNF grammar, which is a very old school thing for formally describing value like what kind of text you can expect inside the text file. And I had to figure out the one for protobuf, which was online somewhere, but I had to modify it a bit. And then eventually I was able to parse it using the instaparse library. It's really great. And then I turned that into Clojure specs. And so let's see. Lost my train of thought for a second. So yeah, I had to write a kind of something that can walk this kind of data structure. And using Clojure spec, I can very easily validate this kind of data structure and know which function I have to call on the Java object to serialize it. So this was the way forward for me to do the serialization part, which was missing from the library that's available for Clojure. So I wanted to demonstrate the power of this. One of the cool things about the specs, which is inside my Emacs, Cider has an option to inspect or search through all your Clojure specs. And that's really handy because you might think, I know inside the game it's called like this, but how would I even get information about it? You just search through and you find the spec. And then you click the spec and you can see all the attributes it has. You can click through all the way to the nodes, seeing the expected data types. And it's really nice just for debugging kind of and learning, exploring the API. So writing the code to turn that kind of spec into actual serialized object was kind of hacky, but it works well enough. So when I finally had that hacky stuff done, I was really happy that I could finally use Clojure to play my favorite game. So I made a video just explaining how to build a bot, how to use it. And this is a result. I kind of scripted a solution to this problem where they have to pick up the minerals. And coincidentally, at the same time, Blizzard opened up like an appeal to say, oh yeah, so here's me in South Korea drinking a STARCRAFT drink with a STARCRAFT hat. Totally going for it. So yeah, at that time, Blizzard and DeepMind announced that they had a conference in LA, and they were about this AI stuff, and they were opening up like you can apply to go there and just tell us why. I was like, I can do this. I worked hard on this stuff, so I made the video, and I was really happy to see that I got accepted. So that was kind of a reward for my work. Yeah. So here I was at Blizzcon. It was a side event next to Blizzcon. We got to go there. For those of you who don't know, Blizzard is one of the biggest game developers in the world. They made a game called World of Warcraft and StarCraft. And yeah, they have a conference every year. It's huge, with all people dressing up as characters from the games and tournaments going on. It's quite awesome. It was also my first time in the US. So this is everybody was there. I'm somewhere in the back. Look at this smiling face over here. That's me. So yeah, and there's people from Blizzard and from DeepMind, very smart people, really cool to be there. This is Oriol Vinyals. He's one of the researchers, I think, leading the StarCraft 2 project at DeepMind. It was very interesting to hear him talk. And this is me. You cannot see the whole thing, but I'm pretty happy because I won in a lottery. I won a collector's edition of the first StarCraft 2 edition signed by the developers, so I was really happy with that. I'm so lucky. So what's there now? So I wanted to do a full stack Clojure and ClojureScript thing, and I wanted to build a UI around the game because you can use the game itself to interact with it, but you cannot do that if you're running on Linux. So if you're on you have a server crunching numbers, then you can basically not see what the game is doing, and it's very Clojure tradition to always know exactly, be able to touch what you're changing. So I wanted to add a UI. So I thought, I'm familiar with the web ecosystem. I like the browser. It's very powerful. And another thing that I wanted to do is to be able to share my machine learning experience and experiments easily. So I figured, what do they do in the biggest language for data science, which is like Python or Jupyter or Julia or R? They use something called the Jupyter Notebook. Probably a lot of you are familiar with it, or at least have seen it. So that's what I did. There's a Clojure kernel for the Jupyter Notebook. So I hacked into it in order to be able to. The way I have it worked out now is I send game state you can. There's a command to run, for example, a bot in with Clojure code, and inside it will be sent to the kernel that's on the back end from a Clojure from a Jupyter Notebook, and then the Clojure server will interrupt it and through WebSockets send the data from the game. So basically, I hacked into the Clojure Jupyter kernel with my server, and then I interact through this way, and this way I added a UI to this project. Let me see, am I going to talk about what I did now? I guess I can. There's one little side thing where I'm happy to talk about kind of front-end-ish web development, which is using Folkrow. This, you can see the namespace data attribute name. This is exactly the same as what the data looks like on the back end, or what the game sends back. And this is on my front end, so it's really nice for code sharing. What's happening here exactly is I won't explain, but basically you're saying this is a front end component, you know, something that you can look at in your browser, and it wants these attributes, and then the logic to get that data is abstracted away really nicely. It's really so little networking code, it's ridiculous. Whereas usually when I make some front-end project, it turns out, you know, it becomes very complicated to merge all the data, and Folkrow has a really nice way of doing that. I really recommend looking at it. Additionally, I can edit the data, this kind of stuff. Like for example, one of my on-click handlers inside the front end basically just sends directly what I would send to the StarCraft client. This is what I would send directly to the StarCraft client. That's really nice to not have to switch context all the time, because I'm in the front end, I'm in the UI, but still I'm just sending directly the data structure I would send to the client, to the StarCraft 2 client. And yeah, so as I said, networking code is great, and local reasoning is also really great. So there's a community that plays against each other, StarCraft 2. There was already one for StarCraft 1 in the past, and now there's one for StarCraft 2. I have not competed there yet, because I didn't really have a bot making framework yet. Now I do kind of. I'm looking to get into that, but I'm working together with another StarCraft 2 enthusiast I met in Korea. He's not South Korean, so that's interesting, but yeah, he's working together with me. He hired a bunch of top-grade StarCraft 2 pros to provide data for us whenever we want, so we can have them train on mini games and then take the data for our neural networks or whatever to learn from. That's really awesome. And so yeah, that's one part that's really going well. So what have I done so far for AI? Because this is all basically just plumbing and infrastructure. And, well, not much, I guess. I wrote a sort of DSL, which is a very Lispy thing to do. You can see this is what you would send to in the Jupyter notebook. You would say execute plans, where the plans are, these, and you can have. I made these 3 types of plans where you can build something, and where you can select something, and you can attack something with what you selected. So I think it's pretty short. It does exactly what it says, and I plan to extend it a bit. It already does some kind of internal. It tries to be smart a bit, so it's not too dumb, and it can beat the built-in AI for StarCraft. That's cool. So I'll show a little bit of, like, if I execute this build function, I get basically a piece of data back. Although the data does contain functions, so it gets a bit contrived, but yeah, I try to make it data focused, and I'll show you what I mean by the environments gets threaded through, for example, to allow to see if there's no collisions. Some unit name, this many, you'd get back this data structure. It looks quite maybe intimidating, but it's actually not that bad, I think. This is basically a list where every key is basically like key and value, so it's almost like a map. And you start at the top, and you get the environment injected. The environment contains the connection to the StarCraft client, so you can query it for there's some things that you can ask the connection. And eventually, and there's also a datalogized version of the game state inside. So over here, for example, I want to add the ability ID to the environment, because later I want to use that ability ID. So then I give it this query, and it will inside the game state find this for me. And once you if you know datalog, you understand the value of this kind of stuff. But if you don't know it, you're thinking, what the hell is this? It's just a very powerful way to grab data from big data sources that you don't know. And yeah, that's why I see the power in it, and I want to show others. So one of my plans is to, well, I'll talk about my plans later, but okay. So I recently did my first AI kind of thing, or machine learning thing, where I was inspired by one of the machine learning Clojure people, a lady who goes by GigaSquid, and she did a short blog post on evolutionary programming, which sounds very fancy, and it is. But she just made a couple of functions that create data, and then she rates the data according to some arbitrary score, of like arbitrary attributes. And then the ones that score highly, the generators that score highly, get to swap some of their code nodes. And then after swapping, they basically generate something new. And this is similar to how our DNA would work, somewhat. And I was thinking this is exactly what I could use on this DSL that I made earlier, where it's like I can build something and I know all the things that I can build, so I can generate this stuff and I can generate the amount, and then just have them battle out by actually trying them out to see which ones score highest. I'm going to use the game score for that. So that's kind of the first big AI kind of test for the project, where I try to run the full game. I generate a build order and see how it performs after a 10-minute game. And you can run I think it's about 10 minutes for 15,000 game steps. You can run it in 12 seconds if you set the step size high enough. And with Clojure, you do mapping a lot, which is you have a collection, you do something for everything in a collection. You can use pmap, which is a bit a forgotten tool, but it makes it so that everything gets executed at the same time. And it turns out that using that, I can run like 10 connections at the same time, or as many cores as I have on my CPU, and run this game in parallel, and then go through generations of these competing build orders, and then find better ones. And it does kind of work. I'm still working on it to make a cool blog post, or maybe a notebook that I can share. So look out for that. Yeah, that's my first AI kind of thing that I did for this project. So what's on their way? So the project is in usable state, where you can see the game be played and you can interact with it on a web page. I guess I'll show you that now. So this is a Jupyter notebook. It's very much in the programmer who doesn't know how to design it, super ugly, but it's functional kind of thing. So I'm in the next couple months, I'm going to make it pretty and add some material design stuff. So it's actually not so horrible. But so here are some settings that you can set before the game. You can change the computer to be very easy, for example. You can save it. And I can edit the resolution that it renders the game at. Since I'm sending uncompressed data, the browser does tend to get a bit slow. So let me start the game by running. Please work. So it's running now. I think it's a step size of 50, where you can see it's building a couple of barracks, and after that it will start building marines, and it will go and attack the enemy. Okay, so one of the things that I wanted to be able to do is basically interact with the game the way you would with the client itself. So we have here the mini-map. I'll render it a bit bigger. So we have here the mini-map and the actual game. Because it's running now, I'm not interacting, but I can actually select like it's the game. I'm not sure what's going to happen now. Okay, so I selected them. And now over here, all the actions that are available as they would be in the game are an ugly ass button over here. And yeah, so you can actually start playing, and when you're testing your bot, you can actually interrupt it and figure out why it's not working, because of course things don't work. You can also watch different types of feature layers, which neural networks love to use things that are more simple. Of course, it's more ambitious to be able to play the game from this kind of beautiful raw data, but it's more difficult. I'll go into future plans. So in the coming months, I will want to be able to bring this kind of to someone who doesn't know StarCraft but is kind of interested and say, okay, how do you write a bot? And I want to be able to write a guided tour where the steps to writing a bot are described, so I can get people enthusiastic about Clojure and some of the technologies that it uses inside. I'm also going to be experimenting myself about things that I find interesting, such as the paper that was recently made by DeepMind and so much other stuff that's going on right now. And I want to be able to make it easy to debug, so inspect the game state and basically make the Jupyter Notebook nice to use. And as I do that, I will keep adding my own experiments. And then in the further future, I would like to turn this into a Jupyter Hub, where many people can make an account and have this, what you just saw, the UI, just by logging in with their GitHub account, maybe GitLab, and then maybe add a way to compete with each other. So you write a bot, play against each other, you get matched or something like that. And maybe if someone is actually very good at data science kind of thing, maybe you can help me out with a Angelican version of a bot, and then you can share the notebook and I'll highlight good notebooks. It's just some fantasies I have. And have a bot that can compete with the wider StarCraft community that I mentioned earlier, and have a bot that can compete with a professional player eventually. So that was all I had to talk.